there. Thanks everyone for coming out. I know we're in the post-lunch kind of lull portion of the day, but I'm Steve Newman. I'm the founder and CEO at Scalar. We're a hosted log management solution. And I'm here to talk to you today about the two sides of logging, generating logs that will help you solve problems, and then how to solve problems with the logs that you have generated. Now, of course, we all know, really the reason I'm here is hopefully to sell some of you on our hosted log management solution, Scalar. But you're going to catch a break because truth is I'm a lousy salesman, hopefully a little bit better of an engineer. And so this is going to be a straight up technical talk. Here's hopefully the clever bit, though. In the second half of the talk, I'm going to show some concrete examples of how you can use logs to diagnose various scenarios. And I'm going to do that through a few quick demos, which we'll do in our product. And I'm hoping that as we go through that, you're going to notice how quickly those demos are flowing. And that's because of the unique backend architecture of our implementation that allows us to search through logs at about 1 terabyte per second, which really enables a very exploratory and experimental kind of interaction with your logs that can make it a lot easier to solve problems. So now the secret's out. Hopefully that'll just be in the background and something you notice as we go along. But now I'll settle in and talk about the topic that you're here for. And so again, this is going to be really in two parts. The first part is going to be about generating useful logs, and the second part is going to be making use of those logs. All right, so what to log? I'm going to break this down into 3 areas, kind of what occasions are worth generating a log message for, what events are worthy of triggering something in your log, what information you want to put in that log message, hopefully enough details to be useful, so not just the fact that an event occurred, but enough details about that event to give you some hope of getting a handle on it. And then finally, you need to give a little bit of thought to what format you're writing all of that out in. And so the first problem is probably the hardest problem. What information or what events are worth generating a log message for? And at the end of the day, this is a trade-off, which is to say it's an engineering problem. On the one hand, to have the most chance of being able to deal with whatever problem or other situation might arise, you're going to want as much information as possible. So you'd like to log every little event that happens through your systems. But in practice, you can never do everything you want. In this case, you would probably generate too much log data. It might overload your log management solution or just be too hard to search through. And there's a limit to how much time you're going to want to spend adding all this logging code to your application. So you have to make little cost-benefit judgments. How much logging do I actually want to put in? How much logging can I afford to put in? How much time do I want to bother investing in this part of the many things I need to worry about? And so a few key areas where you tend to get a lot of value out of a log message. So one is often when you're analyzing a system or trying to solve a problem, it's really about narrowing things down. If you have some very diffuse problem like our site is slow today, there could be a million causes for that. And your first job is always to try to get a handle on where in the system the problem is originating. And a good way to do that is to add logging around the boundaries between systems. So if you're running a microservice architecture or even just 2 or 3 tier web system or something, monitoring the information flows and the operation flows between those systems. So every request and response from one service to another. That's a classic place to start because in addition to giving you kind of an overview of how each service is behaving, it will let you look at those connections between the services, and so you can quickly narrow down on which service is causing my problem. Again, if you're going to log everything, it's nice to log both the consumer and the client and the server side of each interaction. You'll get similar information from both sides, but maybe not the same, especially if you're having a networking problem or a system is backing up and not responding to requests. It might be that those two sides are going to have different views of the timing of an event, or one system may not, the server may have never even received the request from the client, so server-side logging isn't going to tell you anything. So ideally, you log on both sides But if you're going to pick one, you log on the consumer side because the consumer always, or the client always knows at least that it initiated an operation. The server may never receive the operation, so if you log only on the server side, you're at risk of missing out. But the client will always have some information about what's happening. So if you're going to have one kind of logging, it should be on the client side of every interaction between different services or different components within your system. Even within a single service, a single process, if you have major subsystems that are talking to one another, then again, that's a good strategic place to put some logging in. And also, it can be useful to add logging around the internal state of some of these major systems, especially around things like resource utilization, things that might suddenly tip over from being in a good state to being in a bad state. If there's a queue that might fill up or a buffer that might fill up or some other kind of a resource that you can't see into directly from the outside, that's a good thing to have some logging around. And then the other kind of thing that you really want to focus on in your logging is unusual events. And of course, the classic example there is exceptions. Anything that throws an exception in your code, no matter what language you're using on your servers, that's something you want to know about. Now, often the default behavior for an exception might be to just end the request or kill the thread or terminate some operation quietly. And that's a terrible experience if that ever happens in practice, because things are just not happening and you have no information about why they didn't happen, how far they got before they stopped happening. So the one other thing you always want to have in your logging is anywhere in your system, if an exception is thrown, you want to know about that, you want to get the exception message, and you want to get the stack trace. Depending on your language and the framework and environment you're using, there may be a single place you can hook in some kind of error handler, or you may need to, every time you spawn off a thread or create a thread pool, you may need to add in a little bit of code to catch exceptions coming out of that. But you want to make sure you hear about exceptions. Then it starts to get a little bit more subtle. What's an unusual situation? What's worth logging? But anything internally that you're thinking of as an error, a function that you call that returns an error code, maybe it's not throwing an exception, but it's in some other way communicating that something went wrong. If you have internal limits, you're going to discard user input if it's larger than a certain length, or if there's more than a certain number of requests, or there's some kind of cap that you don't normally expect to hit. When you do hit it, you want to know about that. And ultimately, anywhere in your code that there's something you're testing for that doesn't normally happen or you don't expect to happen, if it does happen, you'd really like to have some hint that happened, and logging is usually the way that you're going to be able to get that hint. And finally, any sort of large or important or expensive operation. So that might be creating or deleting a user account or a file or some other, depending on what the interesting units are in your system, but or an expensive processing operation, or sort of anything big is worth logging. Partly because by definition, if it's a big thing, you're not doing a lot of it, and so there's not much cost to logging it, whereas conversely, it may be something interesting that you're going to want to explore. And then we get into the second of the three aspects of logging, which is given that you've decided some event is worth talking about in your log, what do you want to say? So the simplest thing would just be to have a log message, this happened, account created, or error reported. But the more information, the more kind of fielded information, the more parameters of the situation that you can record, the better this is going to serve you when you're actually trying to make use of those logs later on. So again, whether it's an error or just a big operation or a routine communication between two systems, whatever it is you're logging, you'd like to know, how this event that we're logging, how did it happen? How did we get here? If we're a web server, which URL are we processing? Now, you may have an access log that's recording all your URLs. But later in your application logic, if you're logging an error or some other thing, that's not your application, or that's not your access log, that's a different log file. And you're not automatically going to know which URL was being processed when that error occurred or that other internal event occurred. So in every individual log message, you'd like to log a lot of context. What URL led us to this situation where this event occurred, or if we're an RPC handler, which method are we implementing? What remote server or what remote IP address communicated with us that caused us to get to this point? And so if the problem is sort of coming from the outside, we're having a problem because someone is sending something bad to us. That's going to give you that's going to help you figure out where the bad requests are coming from, so that you can start following the problem upstream. The next thing you'd like to include, kind of detail you'd like to include, is what data were you working on when this event occurred? What object ID or file ID or user ID or RPC parameters? What were the inputs to the operation? That may help you understand why it's happening. It may help you try to reproduce the problem locally. If you know an error occurred but you have no idea why and you can't reproduce it, then you're not necessarily very far along toward fixing it. Having a little bit of information to narrow down specifically why the operation failed this time when it's been working fine for maybe for a long time before, that's very useful. Another reason to log things like user IDs is it lets you know who's being impacted by this. If this is a customer-facing problem, maybe you want to reach out to those customers and let them know that you're aware of the situation, or ask them maybe for more information. Do you know what you did to trigger this? So it's another reason that it's very helpful to know who, whether that's a person or a server or whatever the relevant definition of who is, but sort of where did this come from, so I can go talk to them, or I can go query the logs for that system. And then sometimes, ideally, if you're going to try to reproduce an issue locally, you need all the inputs. So that input might not just be a little parameter, an object ID or something. It might be a whole file or some other large thing. You can't routinely log all of the data that passes through your servers, but sometimes for unusual events you can. And I'll show a specific example of that later. But in some of our internal systems, we have code where if we have an error processing some file, we will actually dump the entire file to the server's file system, and then we'll write a little message in our log just saying where that file went, what unique ID we generated for the file. We'll rate limit that, so it can only happen a few times per day. That protects the server hard disk from being filled up. But it means when these rare events occur, we have very detailed information. We have everything we need to go and reproduce the problem. And so let's go through some examples of this. So here's an example of a very unhelpful error message. Array index out of bounds. And I've seen, and you may have seen systems where that's literally the entire log message. Maybe there's a timestamp on the front of it. At 6:03, an array index was out of bounds. That really gives you no information. This could be anywhere in your program code. You don't know what operation was being performed. You don't know where in the code this happened. You have no idea what's going on. And this happens in practice, and always has. I remember there was some software system we used to work with. This is way back in the 80s. There was a file processing system, and its form of feedback was if you gave it something wrong, it would say error in input file. No indication of the type of error, the line number, just wrong. And that was all the information. And you'll see this today in server logs. Sometimes you'll see something that basically just amounts to wrong, try again, but you have no idea where the problem is occurring. And so this is why it's so important to include as much information as you can. So here's one step better, and this is something you might see more often in practice. Something like a Java array bounds check, may tell you at least I don't think it actually will tell you the array size, but it'll at least tell you the bad index. But maybe if you're lucky, it'll give you both of those numbers. This still doesn't tell you directly what part of your code you're in, what operation you were performing. But at least maybe now you get to start a few hints. Start to get a few hints. If it's a very large array, then maybe that's file processing. If it's a very small array, that might be some other kind of processing. So it starts to at least get you a little bit of information, and you might see a pattern across these numbers that might tell you something. This is more like what hopefully you would do in practice if you have control over your logging. So here we have a message, exception escaped from RPC handler. So this might be a catch clause at the top of your RPC handling logic. So it's telling you, this is in your RPC handler. Probably you'd want to say what RPC method this occurred in, but in this case we're not going to bother because later on we're going to have a stack trace, which will make it very obvious which method was being processed. But all right, we're in an RPC handler. Here's the message from before. It's array out of bounds with these parameters. And then we'll add in some contextual information. This RPC that we were processing, it was on behalf of this user. We were being invoked from this other server. Maybe there's some other context. And then a stack trace. So suddenly we're in much better shape. We know what the stack trace tells us exactly what part of the code to look at. So we know what subsystem, we know what exact line of code. This might allow us to reproduce the problem or just sort of directly spot the problem in the source code. We know who's being impacted. If we think the problem really lies in the system that's feeding us, we know which server that is, so we can start to trace this problem upstream. So this is the kind of information that will let you, start going directly to the problem instead of just being at the beginning of a wide hunt. And then maybe the best case, so this is the same as before, but now we have this, I was mentioning, a trick sometimes is to log, if you have a lot of data you'd like to log, write it out to a separate file, because your log management solution might not be a good place for that, but log it to a file, and then the log just tells you where that file is. And you have to rate limit this because you don't want to overload your server file system. But for rare events or for sampled events where you just pick a few and log those, this can be very practical and very, very, very helpful in going straight to the root cause of a problem. And then finally, we need to think about the format for all of this. And there are kind of two classic schools of thought for log formats. One is, the human readable, or at least engineer readable. And this is just your classic printf debugging statement. So maybe you have a few kind of header fields, a timestamp and a server name, some kind of message, and then there might be a few parameters in there. In this case, here's a content encoding of the data we were working with, and here's the length of that data. So this is approximately English. It's approximately easy to read. But it's sort of a mess for an automatic log management system to try to process. We can build parsing rules that will handle this kind of a message, but it requires a little bit of manual work. So it's maybe not ideal. And there may be some systems that you might be using that really wouldn't be able to work with sort of unstructured message like that. Then maybe a little bit more modern trend is to use something like JSON logging. So this is very easy for a computer to work with and to extract fields like those two parameters of the content encoding and the size, as well as more basic fields like the time at which the event occurred and which server it happened on. But it's a lot more verbose. It's harder to read. The first thing on the line here is a bunch of punctuation and the word timestamp. Every log message is going to start with that same word timestamp. So the place where your eye goes first, it contains no information. And the information you care about is kind of scattered around, and it's buried. There's no white space. It's buried in a bunch of punctuation. A really practical compromise is to have a format that's designed more for readability, but is very uniform. So you can have something like maybe every log message has a timestamp, followed by the server name, followed by some kind of message with no fields in it, but just what happened. So here it's decompressed a request. And then a series of key equal value pairs. So this last part is sort of like JSON, but we've dropped the curly braces and the quotes. This is still very machine parsable, but it's also pretty easy to read. It's actually a little bit terser than the original sort of naive log message. So it's really not that hard in practice to strike a compromise where you have something that's both easy to read and easy for a computer to parse. And so this is sort of the style that we recommend. And the other important thing about what to log is that you should iterate. This is like any other engineering situation. You're never going to get your logging perfect on the first try, and there's no reason to attempt to do that. Like anything else, like any other part of your software engineering, it's an ongoing process. So if you have a problem that you're trying to track down, and you don't have any log data to answer that question, well, that's unfortunate, but it'll happen. But make sure that you then go back and add a little bit more logging, because if that problem happens again, and problems often do, or if a similar problem happens again, you'll be better off next time. Sometimes, and this is actually common, there'll be a problem, you manage to track it down, it's tedious, it's a long chase. You have some logging that kind of steers you in the right direction, but maybe it's some work to figure out what's relevant, and then you have to do a lot of correlating different parts of it, or it's not really presented in quite a way that's going to let you go straight to the problem. So you can tough it out in that scenario. But again, especially if you think this is going to happen more than once, go improve your logging. Maybe include a little bit more information, add another field to that log message that is going to give you a little more context and help you get straight to the problem the next time it happens. Conversely, sometimes you can have a problem just of the form that your logs are too noisy, there's too much log data. It's slow to process, it's expensive to process, it's overloading your log management solution. And so then you might remove some of that logging, but often a sort of a defter approach is to put in a rate limit or do subsampling. So if I have an operation that happens thousands of times per second, maybe I don't want to log it every single time, but I'll roll a random number and log it 1 time in 10 or 1 time in 20. You'll still have a lot of information about that, but suddenly the log volume will be much, much more manageable. And it's not hard to create little libraries for yourself where that do rate-limited logging or subsampled logging, and then it's just as easy. Once you have that little utility in place, then it's just as easy as logging directly, and it lets you strike that compromise between too much data to be practical to manage versus not enough data to help you track down problems. And then just briefly, a few advanced tips. So we talked about rate limiting. And sometimes you want to think about that in advance rather than waiting for something to go wrong. As a log management service, it's not uncommon for us to see one of our customers suddenly start generating 100 times their normal log volume for a few minutes or a few hours, usually not longer than that. And when that happens, it's because something has gone wrong at their end. Maybe the database server has gone down, and every request into the web server that used to log a one-line message is now logging an entire gigantic stack trace, or is frantically retrying and happening over and over and over again. So when something goes down, then suddenly the errors that normally are very rare become 100%, and you get these massive amounts of log data. With us that tends to usually be fine, but depending on your log management solution, you may get overwhelmed. That might start crowding out the data that you really need to see to track down what the problem is. So sometimes you want to think about, instead of waiting for something to flood your logs, think about what are the places where, if the system is melting down, where I'm going to get spewed with error messages, and put some kind of rate limiting in advance. Another really useful technique that we don't see used very much is if you have any mechanism in place for adjusting the behavior of your system at runtime, if you have some kind of a configuration tool or a feature flag tool or something that lets you tweak behavior at runtime, connect your logging to that because there may be places that you don't normally want to log, but when a certain kind of problem is happening, you'd like to turn that logging on. And if you can do that just by flipping a switch as opposed to creating a new build with an extra log message in it, that can make your investigations go a lot quicker. This is especially helpful if there's something where you could just never log all of the events even temporarily, but you have a specific issue you want to focus in on for a particular operation, a particular page on your site, requests from a particular user or a particular IP address. If you can put something in place where you can use a configuration flag to enable logging in that kind of a selective fashion, only log for a certain parameter value, a certain client IP address or some other thing, then you can go in and be very surgical, and without sort of flooding your system with logs, you can quickly get detailed information about some specific issue that you're trying to track down. And one other little tip is if you're working in a multi-threaded environment, say in Java, your log is going to contain messages that are interleaved from potentially a lot of different threads. Your system may be processing dozens of requests in parallel, and those log messages are going to be interleaved. It can be sometimes, if you're logging sort of detailed debugging statements, it can be hard to make sense of that. If you put a thread identifier into your log, then suddenly you can see exactly what's the chain of events on a particular operation and untangle that. All right, so that's the first half of my talk about what to log. So now I'll spend a little time talking about how to make use of your logs. And I'm going to focus in particular on troubleshooting. So this is a pretty broad topic. I'm going to define it in a very particular way. Troubleshooting is connecting the dots between a symptom that you've observed or that's been reported to you and the root cause that you're actually going to be able to do something about. So when you're in a problem-solving mode, there's a reason for that. Something was brought to your attention. Ideally, it was brought to your attention by your automated monitoring, but maybe a user reported a problem or you noticed something funny yourself. But that's always going to trigger off of a symptom. The site is loading slowly. Some system is returning errors. It's not a root cause. It's not something you can't push the stop serving errors or run faster button. You're going to have to connect that symptom back to a cause that hopefully you can do something about. And when you first sit down, especially if it's sort of a vague problem, like things are running slowly, that investigation can be very daunting. You've got lots of log data. You also have metrics and other kinds of data. So you've got all kinds of data to work with, all kinds of moving parts in your system. Where do you even get started? And so a simple rule of thumb is identify a log that has information that directly connects to the symptom. So if the symptom is performance, something's happening slowly, then hopefully you have a log that's recording that performance. Often a web access log will record the server-side processing time for each request. So that'd be a great place to start for a performance problem. If your system is returning errors, you may have a log that's showing exceptions, or you may have a web access log that's showing 502s or 500 status. So somewhere there should be a log that's recording whatever the symptom is. If the symptom is that something is overloaded, then look at a log that records all the activity in that overloaded system. Then once you've identified that relevant log, you can start using your tools to break down the data in that log. One of the nice things about logs is they're highly dimensional, especially if you've been doing your logging right. And also a lot of off-the-shelf kind of logs you'll have, like a web access log, are like this. There's a lot of dimensions, a lot of fields in that data. A web access log will tell you, what was the client IP address and user agent, and what URL was being loaded, how long did it take to process, what was the referrer. There's all these different pieces of information in that log. Which server, did you process the request on? And so you can look at your data broken down on all these different dimensions. If I'm serving errors, are all my servers generating errors, or is it one particular server? Are all of my URLs having problems, or is it one particular URL on my site? Is it all of my traffic, or is it traffic from one particular IP address? Often just a quick scan, if your tool can give you that breakdown, then just a quick scan will point you in the right direction much more quickly than just sort of brute force trying to page through a gigantic log file and spot the pattern in it. So in a moment, I'm going to illustrate that in a demo. But then once you've found that pattern, all the problems are with requests to this one service. Now you don't have your root cause, but you're one step closer. And so now you want to go investigate, why is that service misbehaving, or if it's a problem with the database, why is the database, if my performance problem traces to the database, why is the database being slow? Or if all my errors are on one server, what's going on that server? So now you're one step closer to the root cause, and you're just going to start this process from the top. For your next level problem that you've identified, find a log file that will bear on that problem, and kind of rinse and repeat, and hopefully eventually you get to a root cause that you can actually repair. So I'm going to go through a quick demo to illustrate that. So here we're looking at just a simple kind of overview health dashboard for a cluster of web servers. And I'm going to highlight this one particular graph that shows the server-side processing time. And we can see that there are some huge spikes on this graph. And so it looks like there's some kind of recurrent problem happening in our web cluster where we get some kind of a performance issue. So I'm going to click on that graph just to zoom in. And now this graph, because we're a log management solution, we're generating this graph on the fly from web access logs. And what that means is we have a lot of that dimensional data behind this graph, and we can see which servers are handling this traffic, and which URL is being requested, and a lot of other features of the data. But before I look at that, dive into that, I want to look at the spiky nature of this graph. So you can see we've got 3 different graphs, or 3 different plots here. We're showing the 99th percentile, the mean, and the median page generation times on this server. And that 99th percentile is spiking so high that it's kind of crushing the y-axis and making it hard to see the other plots. So I'm just going to uncheck those one at a time and just look at the median. And I don't actually see a problem here. So on this plot, whatever, that event isn't occurring. So that tells me that if my median page load time is not having a problem, not having spikes, but these other 2 statistics are having spikes, that tells me that whatever is going on, it's affecting less than half of my traffic. And so I'm going to go explore that directly a little bit. I'm going to go to the time field, which is the y-axis on this graph, showing how long these pages are taking to process, and bring up what we call the distribution view. And so this shows the breakdown of values in that time field across all of the logs that I'm looking at. And I can see that actually the most common measurement in that field is 2 milliseconds. A lot of my pages are being processed in just 2 milliseconds, and almost all of them within 50 milliseconds. So those spikes I'm seeing must really be a long tail issue, because we have some pages that are taking 10 seconds or more to process, and that has to be what's driving those latency spikes. So I'm going to drill on that. I'm going to add a term to my search where I only look at requests that took at least 1 second to process. I'll click Update, and it's already come back. And so now I can start to explore just for these slow requests. I'll look at the server field, and I can see that there's some lumpiness here, but really I have a lot of different servers that are generating slow responses. So it's not a single server problem. They're all for one page, though. So I have a lot of different pages on my site. But now that I've added this filter term, I'm only seeing requests for one page. So that might start to give me a hint of what's going on. But just for fun, I'm going to flip over to the raw log view. So here's the same data we've been looking at all along, but we're finally seeing it in the raw form. Everything else we've been looking at have been visualizations and summaries of this log data. But here are a bunch of the individual requests with these time measurements that are 1 second or greater. Now in this particular log that we're looking at in this demo, each log message has a request ID, a unique ID for a particular user request as it flows through the system. And I'm going to click on one of these IDs and click the New Search button. So it's going to blow away the search I had in place where we've been filtering on requests that took at least 1 second to process. And instead, we're just going to search the whole system, all servers, all logs, for every message that contained that request ID. And so we can see this request flowed through a couple of different servers, a web front end and an application server, and generated about 8 messages along the way. And one of these, I don't know whether any of you guys can actually read this, but there's a funny error message on one of these log messages. So it wasn't the message I was looking at before. It wasn't the one that recorded the elapsed time, but a different message that popped up while processing that same request has this funny error message. And maybe if I'm an engineer working on this system, I may know enough to know that that's an unusual message. Maybe I've never even seen it before. And I'm wondering, is this a fluke? Have I just stumbled onto some little anomaly, or is this something that's happening a lot? So I'm going to select the error message, click New Search again, and I can see that we've got a flood of these errors, and the graph shows me that they're clustered in time, and the clusters have the exact same spacing as those performance spikes that we saw at the beginning of this. So now we have a pretty strong hint that whatever this funny error message is, it's probably connected to my performance issue. And so now I have a deeper issue to investigate. My next step might be to go to the source code and search for that error message and see what causes that to occur. But just as a finishing step, and this will be motivated by what I'm going to talk about next. Now that I've found this search query that's revealing something about my system, searching for how often this error message occurs, I'm going to save that search query. I'm going to invoke, there's a command here, add to dashboard. I'm going to call this, I'm going to type in the name of that error message, inconsistent friends list. I'm going to, see, do I have, yeah, so I'm going to put it in a dashboard called Troubleshooting, and I'm going to save that. And so I'll explain why I'm doing that in a moment. So that's the troubleshooting demo. And just to say briefly, things you can do to help yourself out on troubleshooting, to set yourself up in advance to be able to track down problems. Just one thing I'm going to highlight is it's really useful to be able to have a logging solution that's extracting structured fields from those logs, some kind of a parsing mechanism, whether you have to use JSON or you can do something a little bit more readable and sophisticated, but somehow be extracting structured data from those logs. That enables a lot of the exploration I was doing there, where we were looking at graphs and histograms of response times and looking at other kinds of breakdowns. You need to have those fields pulled out of your logs so that you can have a tool that lets you do that kind of exploration, and that's how you get away from just paging through page after page of logs and trying to spot something visually into being able to do that much more focused exploration. Okay, so now I'm going to talk about another aspect of problem solving, which is firefighting. So firefighting is basically just troubleshooting, but under time pressure. This is what we would call it if the problem you're solving is really urgent and critical. Your site is down, or somehow your business is really being impacted. Users can't get work done. So now you have to track down the problem to fix it, but you have to do it in a real hurry. Now you can't just turn on smarter mode when things are urgent. You're already working as efficiently as you can. So what you really want to do to set yourself up for success in firefighting is hopefully have some ability to anticipate what the problems are going to occur, what problems might be most likely to occur that are going to put you into a firefighting mode, or at least what category of problems. And have not only logging data that you're generating that will help you track those down, but set up some saved searches or some dashboards or some kind of pre-built searches and visualizations that are going to let you very quickly narrow in on the relevant scenario. And so that's why and one common way to do that, problems tend to repeat, if not precisely, then at least related issues. And so every time you have a problem, whether it's a crisis or hopefully a smaller problem, one of the things you want to do in your postmortem is think about, how could we have tracked that down more quickly next time? And often, and that doesn't need to be very sophisticated. It could be, whatever the search through my logs, whatever search I did, the last step in my exploration, the one where I got to the aha, here's the error message, or here's the critical little piece of information. Just throw that search into a dashboard, or save it into a list of bookmarks. And then next time you have a problem, you can just quickly check that. You don't need to go through the exploration. You don't even need to remember, wait, what's the phrase I need to search for? You just go to the bookmark, boom. That lets you very quickly rule in or out scenarios that have occurred in the past. So I'm going to do a demo of this, and it's going to make it look so easy that it's almost not a demo. It's going to feel like cheating. But so let's say I go through that same scenario again, where we've noticed or someone has reported that we're having latency spikes on our system. So I'm going to go to my troubleshooting dashboard where I've saved that graph. And now imagine I may have dozens of graphs here for various different issues that have come up over time. So I can just scroll through this, and your eye is going to be really good at picking out, that looks normal, that looks normal. Whoa, look at those spikes. And so now we've immediately identified what kind of problem this is and jumped directly to the last step of the demo I did before. But if I need more information, because this is, again, a log-based graph, I can click on that graph. I can flip around to the raw log view if I want to see that, or I can start exploring all the different structured fields. So not only have I gotten a quick pointer to what might be going on, but I'm also right in the tool that will let me explore that in more depth. So again, things to set yourself up for success are, first of all, record queries that bear on past problems you've had, and also just, kind of general rule of thumb is, because often we're running very complicated services with a lot of different services or moving parts. You may also be relying on a lot of third-party services, from AWS or elsewhere. If you can give yourself an overview dashboard that has one or two critical parameters, error rate or latency, or whatever the critical parameters are for each of those services, that again gives you that at-a-glance view. Right? Here's a bunch of graphs. Which one looks funny? And then you have an idea of where to start digging in. Okay, and I think given our time, the last topic I'm going to touch on briefly is load analysis. So this is when this is looking at how some resource is being used up. We often think about things like network bandwidth or disk I/O or CPU usage. Maybe my site has started to bog down because our CPUs are overloaded. There are a lot of other things that really are resources and can be used up that we don't necessarily think about that way, like a fixed-sized buffer or a memory pool in one of our servers, or a queue, an email queue or some other kind of queue that between two parts of my system. That queue might have a fixed size, or maybe if it's just backing up, maybe it's not going to hit a specific limit, but it's running slower and slower because it's filling up. We have a data structure with a lock, and we're contending on that lock. These are all resources that once you start to use too much of them can suddenly out of the blue cause a problem. And so you might want to analyze that. Either you're in troubleshooting mode, you have the problem and you're trying to figure out why, or you're trying to keep a look ahead and do capacity planning and make sure you head off the problem before it head off that usage before it becomes a problem. Here you need log data that measures the usage of the resource. If usage comes in sort of uniform lumps, you're running an image server. All the images you're serving are 32 by 32 icons. Any image is the same size and cost as any other, then just counting every request is fine. But if sometimes you're serving little icons and sometimes you're serving 16 megapixel giant pictures, then the cost of one of those operations may be very different than another. Now you really need your log to record some kind of numeric measurement of what's the image size, or what's the cost, the size, the processing time, the complexity, whatever the relevant cost is of this operation. And then that will open the door again for you to use tools to use your log analysis tools to track things down. So I'm going to go back to this same dashboard, but this time I'm going to go to a different graph, response bandwidth. So this is showing us the total amount of data that's coming out of our web server. And we're generating this from the access log just by each record in the access log records the amount of data, the size of the response, the amount of data that was generated by the server for that page. We're just adding those up and graphing it. We call that the sum per second operation. Add up all the response sizes and plot it per second over time. So here we see the total bandwidth usage in our web server. And I'm going to break that down by the URL. And so I can immediately see which pages on our site are using the most bandwidth. And we have a pair of URLs here associated with image rendering that are using much more bandwidth than everything else combined. We have a lot of other requests that return HTML, but these two requests return images. The images can be pretty large. And so this immediately gives us information about what's using up bandwidth on our web server. Now, if I go back to this breakdown I've shown earlier over here, which just counts operations, the URLs that show up at the top of this as the most common URLs are very different. So this gets into that importance of logging the expense of each operation. So our most common URLs are not image serving. Maybe the images tend to be cached or something. But if we're looking at bandwidth cost, it's all about the images. And so you need to make sure that when you're doing analysis that you're looking at the data in the right way that directly reflects how much each operation is actually costing you. And hopefully you have a tool that will do that for you. And so, things that you can do in advance to set yourself up for that. Again, you want to have a log message for every expensive operation. So maybe if you have an image processing system, maybe you don't log the little requests where you're processing an icon, but if an image is above a certain size, then log those requests. Log the information that indicates how expensive this was, how long did it take to process, or how much data there was. And log information about why you did this operation, which user requested it, or which file you're operating on, or whatever is going to help you break this down and sort of assign a source. And then maybe, again, throw that in a dashboard so that you'll be able to get to it quickly. So that's about all the time we have. Again, thanks for coming by in that difficult post-lunch period. But if you'd like to see or hear more, we're next door in the exhibit hall. You can stop by, talk, get one of these attractive and oh so clever T-shirts, and hopefully we'll see a few of you. Thank you.